This is question number 18 for the ACT math exam I'm working through, and this one is going to test your ability to divide exponents and really to work with fractions with exponents in them, right? So here's the question. For non-zero real numbers x, y, and z, the expression x cubed y to the fourth z squared over x y to the sixth z cubed is equivalent to what? Alright, so just let me clarify a couple things. One, we're just talking about the real number line here. That just means the regular old number line, and not zero in this case, but this is the number line, and it's got 1, it's got 1 and 2/3, it has negative 0.7 repeating, it has the square root of 2 somewhere. So all of those numbers, all of those, irrational, rational, natural, counting, etc., etc., those are all on the on the number line, and they're all real numbers. So the other piece is that I think the way exponents are taught sometimes can be confusing when you get a problem like this. So for example, you're taught, all right, well, when you multiply exponents or variables with exponents attached to them, then you just simply add the exponents, right? Which is true. So x cubed times x squared would be x to the fifth, right? Because it's 3 plus 2 equals 5. And then if you have something else where, let's say, you're dividing, you have x to the sixth divided by let's say x squared. It's just simply 6 minus 2, which is x to the fourth, right? So that seems all fine, but then what do you do when you run into a problem like the one we've got here, right? So for example, you see the middle variable is y. Well, if you have, or let me start with x. So x, x cubed over x maybe seems pretty straightforward because x is just x to the first, so it's 3 minus 1, and you get x squared, right? So hopefully that makes sense, but then what if you have something like the middle term there, y, up there in the problem, and you have x to the fourth minus y to the sixth, or divided by y to the sixth. What are you supposed to do? Are you supposed to subtract 4 from 6, 6 from 4? Is it supposed to be y squared or y to the negative 2, or what is it supposed to be, right? So there's a simpler way to do all this, and let me just get rid of most of this stuff here, and we'll take a look at a different way to do this. So let me line up the problem we have here in a little bit of a different way. I like to just, if I've got a big complicated problem, I'd like to just write out what I've got. So I know that I've got 3 x's, right? So I've got x times x times x, and then I've got 4 y's, so that's times y times y times y times y. And again, I'm just doing the top here, so I've done x and I've done y, and I'm going to do z. And so then choose a different color here. So then that's times z, right? Because I've got 3 x's on top, 4 y's on top, and 2 z's on top. So then let me draw the line, and then underneath I've got, going back to the x's, I've got just the 1x, and then I've got 6 y's. So that's times y times y times y times y times y and times y, and then I've got 3 z's, so that's times z times z times z. There's my problem. So sometimes it's simple just to visualize it this way. So let's check it out. What do you do when you have a fraction and you have the same thing on the top of the bottom? You simply cancel, right? So I can cancel 1x here and 1x here. I can cancel 4 x's on the top and 4 on the bottom, right? I can cancel 2 z's on the top and 2 z's on the bottom. So if I rewrite my equation again, then I'm just going to use one color to do it. I'm going to have x times x on the top, and then I'm going to have what? Y times z, right? So I'm going to have what is x times x is x squared, and then y times y is y squared, so it's y squared times z on the bottom, right? And so as it turns out, our answer is F. So, but you can see that the really easy way to do this is just figure out what you've got on the bottom and top and then just cancel. That's the easiest way to answer questions with multiple variables in fraction form with exponents.